Example, we're going to determine whether an ordered pair is a solution. Now we have to understand what a solution is. A solution is a value or a number or an expression that when substituted into an equation or an inequality will make the statement true. So if we want to test whether this point is a solution to that, we substitute the appropriate values for x and y. So this would be our x value, this would be our y value, and we determine whether it's a true statement or not after our simplification. So we would have 3 times negative 4 plus 4 times 2, that's our x value and that's our y value, and we want to know if this equals. So when you have your equal sign there, throw a question mark on top because we don't know if it's a true statement or not yet. And then we say that we're not sure if it equals negative 5, but that's what we wanted to determine. So here we have this product will be negative 12. This product will be adding 8. And does that equal, again, keep your question mark up there because we're still not sure. And negative 12 plus 8 is negative 4. Does that equal negative 5? And of course the answer is no. So therefore we know that this point is not a solution. To that equation. In this example, we're going to determine whether an ordered pair is a solution. Now, in the previous example, I demonstrated that the point was not a solution because when we substituted the values into the equation, it did not make the statement true. So, you more than likely can assume that this one is going to make it work. But let's demonstrate that. So we have our equation, 3x plus 4y equals negative 5. And if we want this to determine whether this is a solution, remember a solution is a value or a coordinate that when we substitute it into the equation, it makes the statement true. Very important. So if we take this negative 1 and substitute it in for x, because this represents our x and this represents our y of the coordinate, then we have plus 4 times negative 1/2. And again, I love the structure of writing the parentheses for our products as well as the question mark because we don't know if this is true yet. So we can't have an equal sign there. So we're asking if this is true so we can determine whether it's a solution. So here we have this product of negative 3. We have 4 times negative 1/2, so we know we're going to have a negative. When you think of this, you might consider 4 times a half. We have 4 halves. So how many do we have in total? Well, 4 halves. 2 halves represents 1. Another 2 halves, or 4 in total, represents another 1. So this equals 2. So if you can think logically, that's one way to look at this. Or you can think of this as a product of 2 fractions. And when we multiply 2 fractions, we know that we multiply the numerators and then we multiply the denominators. So we would have 4 as our product in the numerator and 2 as our product in the denominator. And we still don't know. So we leave this structure in there. Does this equal negative 5? And now we can simplify over here on the left-hand side, because negative 4 divided by 2 is 2. Does this equal negative 5? And the answer is, as I told you earlier, that the answer is yes. This does make this a true statement. And because it does make it a true statement, we can say that this is a solution to that equation.